So we started the recording. Okay. So good evening to one and all present here. So this is session three of week three, and it's mostly about the introduction of the statistic and the probability, which is covered. So first week we talked about the R language, and then that is all about the programming, where you are going to apply and all. Second one, we talked about the linear algebra, and this is the third week. We are talking about the probability and the statistic, which is these all subjects are kind of an individual subject in itself, but we are going to learn this for the further study of the data science. Okay, so this is the introductory course. That's why. So first of all, we will go through the basic terminology of the um, probability and statistic, and then we will solve the numerical so that we are going to cover a short kind of a summary or the overview of the week, and then we will solve the questions based upon that that will help you to solve your exercises. So the first one term is the random phenomena. So from the name itself, it's any phenomena which is random is called to be the random phenomena. So let's go to the definition of it. A phenomena or experiment whose outcomes are not predictable with certainty are called to be the random phenomena. So here I gave an example of a dice. So let's consider you have a dice. You are playing snake and ladder game, and you just thrown the dice, so you don't know what kind of output you will get. You will either get a six, either get a one, three. You don't know. It's depend how you throw and how you move or that particular dice. Okay. So there, this particular kind of phenomena is called to be the a random phenomena, where what output you are getting out of that experiment you don't. Same with the coin toss. When there is a match of between the India and England going to happen, you toss the coin, you don't know which one is the head, or means whether it will give you the head or tail, you don't know. So it is going to give you some random output, and that random output experiment is called to be the random phenomena. Okay. So that is clear, I think. Then sample space. So when we have some random phenomena, you will get kind of some outputs out of it. So in case of dias, you will get either one, two, three, up to six. That are possible kind of outputs you are getting. So if you consider or combine all those outputs together, that call to be the sample space. This many of the outputs I can get out of it. You will not get seven out of it because you only have the one die here. If you have the two die, then it's possible, but with one die, it's not possible. So it's total number of possible combination of the possible output you will get. If you combine all them, is called to be the sample space. Okay, that's very basic thing. Okay, then there is an event. So if you apply some condition to this particular sample space, that is called to be the event in simple words. Okay, any subset of sample space means when this is a superset, and subset means it's some portion of these particular outputs you will get here. That is called to be the subset. So output, here I give one of the example. Output is greater than three. So which outputs are greater than three? Four, five, six are greater than three. So that will, here I applied kind of a condition which is greater than three. So it becomes an event because it's a subset of a sample space. So out of all one to six, you are getting four, five, six as a event output. Okay. So here we learn random phenomena, then sample space. So basic word, anything which you will get a random output, you don't know what exactly the output, it's a random phenomena. If you consider all possible combination combined together, that is called to be the sample space. And when you apply some condition on it, and you will get some kind of output out of it, that is called to be the event. So that very basic definition of the random phenomena. Now, I want to represent such kind of things, whatever we discuss right now, in some mathematical form. So for that, mathematicians derive a particular terminology which is called to be the probability. So most of the time means whenever while discussion and all, you will use the probability word, okay, where, or the percentage word. What's the winning percentage? I mean, what's the probability or the what is the percentage you thought that India will win against the England? Or so you also saw there are, when the voting is going to be happen in India, so they will say that the percentage means they will take the votes from the different people, and based upon that they will say the BJP is going to be win in the elections and all. So what they are doing, they are just they are taking a sample space, means around some people, and based upon that, they will say to whom you are going to vote, and based upon that, they will do means particular BJP, how many people BJP voted, and number of people total voted to all the parties. So that's how this percentage, or you can say the probability, is calculated. So we want to convert this random phenomenon, because in case of the voting, a person can give their vote. Like now the Delhi elections is going on. So here you don't know the particular person giving vote to AAP, or BJP, or Congress, or any other party. You don't know. So that is also kind of a random phenomena where you don't know what's going to be the outcome is going to come. So right now we want to convert this particular thing into the mathematics form. So for that, the probability is designed. So probability is a measure that assign a real value, means some mathematical value, to every outcome of a random phenomena. Okay. So whatever the phenomena is going to be happen, we are giving some meaning to it. So while saying something, it has some meaning. Okay. So what probability? Probability is a ratio of number of ways an event can happen to the number of ways sample space can happen. Okay. So again, take the example of a Delhi election. So in Delhi election, let's consider there is a population of Delhi. Assume that 2 to 3. Okay, let's assume that 3 crore population, and you choose some around 1 lakh people to vote. I mean, ask them to whom you are going to vote. So from that, so here your sample space. Okay, here your sample space is this bottom one denominator. So that is 1 lakh. And from that 1 lakh, few people will vote BJP, few people will vote going to vote up. So if you ask someone what is the probability of winning the BJP, so based upon that, this particular you can say you will put BJP number here, and here you will put total number of 1 lakh people. So let's consider 50K people voted BJP is going to be win. So you will have 50K divided by 1 lakh, so it becomes 0.2. So the probability of winning BJP becomes 0.2. Or you have there is a 50% of chances of BJP winning. So that is what basically funda behind the probability. Okay. So that is it's very simple. Total number of outcome means total number of samples or the outcomes you have. From that, when you apply some condition on it, so you have to you have to take all those outputs, calculate all those outputs, and just divide it. That will give you the probability. Okay, someone said that I am hardworking. Nice to you like the okay, you like the example. Okay, fine. So axioms of probability. So axioms basically you can say the rules of the probability that mathematicians told that. So the rules are as follows. So probability can't be negative. It is always between 0 and 1. So based upon this ratio, you can with the help of this ratio, you can understand that if there are some outcomes, and if there are always this value is equal to the outcome, okay, or below the outcome. So this is means, and outcomes means whatever the outcome you will get. Let's consider if you throw the die and all, so you will get 1 to 6. There is no any negative thing you will get either in sample space or a thing. So there is no any negative sign in this formula. So there definitely it is non-negative term. Okay, as well as this is the highest value, and this is either a highest value, it will go till sample space or below that. So definitely whenever you calculate the ratio of such kind of thing, your value will not go beyond 1. Okay, when your value will go beyond 1, when this particular bottom value means denominator value will be less than the numerator, and that's why its range is between the 0 to 1. Okay, now probability of whole sample space is equals to 1, means if your this particular condition is exactly, means if out of all the you selected the members, okay, 1 lakh members in the election, and they only gave vote to single party. Okay, so here probability becomes 1. So that's what exactly this statement means. Probability of entire sample space is 1, because your entire sample space give vote to a particular single party. That's now, this is probability of A union B is equals to probability of A plus B for mutually exclusive event. So we will see in the next coming slides what exactly this means. Okay. So for now, I will not explain what exactly means. We will see when we see the Venn diagram and all what exactly it means. So we will go to the numericals. So these are the numericals help you to understand the probability concept more better way and help you to solve your exercises. So our first question is, what is the probability of rolling an even number of fair-sided die? Fair-sided means your normal die, okay? And some if in some of the question it will say bias die. Bias die means you consider the example of Mahabharata where Shakuni Mama having that dias, which what he want he will get that. So that is called to be the bias die. Here fair die means what you have exactly that kind of die. So most of you answer it as a C. So yeah, your answer is correct. So those who are not able to answer, so we will see why it's means why what exactly the reason behind it. So even number. So here I told that what is the probability of ruling a even number. So first of all, those who don't know even number means any number when you divide it by two, you will get a remainder is equal to zero. That is called to be the even number. So 2, 4, 6, 8, all those are even number. But right now we have a sample space from 1 to 6. From that 2, 4, 6, it will end your number of even means when you throw the die till 6, you will get the even number. So how many numbers are these? 1, 2, 3. So that's the n of e of even number, even number is equals to 3. Then your sample space means how many outcomes I will get out of it. So you will get 1, 2, till 6 outcomes you will get. So I measure till 6, n of this my whole sample space is equal to 6. Then simple formula, n of e divided by n of s. So 3 outcomes divided by whole sample space 6. So you will get a half. So the chances of getting even number is means 50% you will get the chance because out of 6 you will get 3 even numbers always be there. So it's a 50% chance. Moving towards our second question. If two fair coin are flipped, what is the probability of getting exactly one head? So right now I am throwing two coins together. First I will throw one and then I will throw another. So what is the probability of getting exactly one head out of it? Okay, so yeah, most of you answering B and A. Okay, so those who answered A, so let's understand why it's not answer A. So getting exactly one head here, it means I means when I throw the okay, so I will first explain the sample space. When you throw your coins, you will throw first coin and then you have two coins here. You are not going to throw first coin again and again. So you have two coins. First you throw one, so you will get this kind of a combination. Either you will get head, head, tail, head, or tail, tail. So this kind of four combinations you will get out of this. So here I ask, two fair coin are flipped. What is the probability of getting exactly one head? So exactly one head you will get here. Means I don't want two heads. I want exact one head. So this is one combination and this is second combination. That is what I mentioned here. So there are two possible combinations you will get, head tail or the tail head. Okay. So here you have two combination and four sample space, four ways outcomes you will get out of it. So just simple again formula 2 by 4 it will give you the 1 by 2. So here one who answer 1 by 4. So that's the wrong answer. Maybe you assume that exactly one head. Okay. So just be conscious while reading and reading the questions. Okay. We saw the kind of example of a dice. Let's move towards some playing cards examples. So here you know that in playing cards there are 13 means spade. There are total 52 cards, out of which 26 are red and 26 are black. Spade, diamond, all those stuff. So a deck of a playing cards contains 52 cards. That's what I just told. What is the probability of drawing a red card, hearts or diamond? Here I'm talking about red cards. Okay. So what is the probability if you take your playing cards? So what is the probability of taking the red card? So I'm going to choose one card out of each. So what is the probability I will get it as a red card? So that's what exactly the question. So yeah, so many of you answering it as a A. So yeah, you answers are correct. So those who are not able to solve it, so it, it is very simple. So total number of red cards in the deck, total number of cards in the deck, red cards in the deck is 13 diamonds and 13 hearts. Those are red cards. So you will get 26 cards in your deck, which are red. Now total cards in your deck, it's 52 cards you have in deck. So 26 divided by 52, that's your way you will get the answer as 50. So you will get the answer as half. Okay. Moving towards next question. So right now, these are the very basic examples. I'm just giving the different examples which will ask in the exam generally. A bag. Okay, you have the bag which consists of five red balls and three green balls. What is the probability of drawing a red ball and then a green ball without replacing it? So you have some eight balls which consist of five red, three. So you just I mean suddenly put your hand inside that bag, and you are picking one ball, and then you are picking another ball without putting that again into the bag. So that's what here I mentioned without replacement. And what is the probability of drawing a red ball and then a green ball? So you will draw first red and then the green. So what is the probability? So just think for some time, and then we will go to the answers. Yeah, Venkatesh answered as B, Vandana B. Okay. So all of you answering it as a B. So you all are correct. The correct answer is B. So let's deep dive how to solve this. So when such kind of questions asked to you, so first try to form kind of a tree diagram. Okay, that is very easy. That will help you to solve this question. So the way I follow, or the many textbook follow this way, okay, when you go to the competitive exam and all. So here you have the five red balls and three green balls. So make it R and G to denote 5R and 3G. So that's how you will have the total 5 plus 8 balls you have. Okay. Now, just what here you are going to draw. So this is five red and three green. Okay. Now you are going to draw a red ball. Okay. So what is the probability of drawing the red ball? So here probability how you, so here five red ball, three green ball. So here five red balls you have. So what is the probability of drawing red ball? So this is five plus three, eight. So this is total balls, and from which you are going to draw five balls. So it will become 5 by 8. That's simple. Okay. Now here it is told that another ball should be green without replacement. So if I already drawn this ball. Okay, so right now, how many balls are left in the bag? So I will left four red balls I have left, and three green balls I have left, because that here I'm not going to draw the green ball. Okay, green ball I'm going to draw in another chance. Okay, so right now here 4 plus 3 I'm having 7 balls. So chances of drawing it from is, I already remove one ball from here, red ball in the first chance. Okay, so right now I will minus one, so I become it becomes 4, but I not remove any green ball, so it becomes 3. So that's how right now you have 4 red plus 3 green ball. So chances of drawing the green ball, it's a 3 by 7, because you have 7 balls currently in your bag, and you are removing one green ball because you are following a red followed by the green. And then just you have to multiply this 5 by 8 multiplied by 3 by 7, and that's how you will get end up with this answer. So very basic. So here I asked the question without replacement. If someone asks with replacement, means you can just take out and then again put it down, put it again back to the bag, then it becomes 5R plus 3G. Here whatever the probability will come, and this becomes again 5R, because here we are doing without replacement, but with replacement it becomes 5R if they ask. And here chances of getting red ball, it becomes also 5. So it becomes 3 by 8, and then your answer will be like that. So that's what exactly you have to follow. Same defective and all those items, defective piece in the instrument or the equipments, all those questions you can solve by this kind of a tree diagram. That will clear your means that will clear how to solve this. Okay. Another a bit means similar question. So I think similar kind of question. That's the first question they asked about some number and all, mobile number of a friend. Similar question I took here. So if out of all possible jumbles of of the word bird, so I have some word bird, so I will replace, means I will just change the wordings or the letters of this word bird. A random word is picked. What is the probability that this will be start with the B? So I'm going to I have this particular BIRD, 4 letters I have. So I can form different words out of it. Okay. And what is the probability that that particular word start with the B? That's what I'm going to ask here. So you can answer here your question. Sita answered is a B. Rasaina B. Prakash B. Okay. Let's wait others to solve, and then we will go. Okay, so many of you answering it as a B. So let's deep dive. Yeah, you all are correct. I hope you got the concept, the probability concept. So it's basically so basically there is a concept who not able to solve this. Means those who not means I don't know attended or what to say, but those who forgot the concept of permutation and combination. So in probability, permutation and combination is a very basic concept. So instead of writing each bird word like BIRD, taking all this work and writing all those BIRD, all those combinations. in mathematics, there is a say permutation and combination. So you have to, if you want, if there are four words, so you just have to take a 4 factorial. That will tell you how many possible combinations you can made out of it. So what 4 factorial means? So if someone gave you 4 and then some exclamation mark, it means 4 multiplied by 3 multiplied by 2 multiplied by 1. That's what exactly the 4 factorial. Now someone fixed that I want B to be fixed. Now you can vary these 3 words. So how many way you can vary that 3 word? What many possible combination you can get out of it? It's just a 3 factorial because you have 3 position and 3 words, and you can just make a changes on that. So yeah, this is 3 factorial. So it's just a simple 3 factorial versus 4 factorial. So 1, 1, 2, 2, 3 get cancelled, and you are get 1/4, and that's how 0.25 is your probability. That's nothing but a 1/4. So that's how you have to solve the permutation and combination problem. So if there are two B words will be there, then you have to just divide this by means this 4 factorial divided by 2 factorial because you have two common words. So that's how you can just go through your basic mathematics permutation and combination, and you will get. So don't try to solve this with writing all the combinations. Otherwise, you will lose means your time. Okay. Now we will. I already explained you the event. Then right now we will go in more depth of the event. What are different kind of basic events. So mutually exclusive event. Okay. The definition is the occurrence of one event implies that other event does not happen. Okay, does not occur. Okay. So the simple example here given with the help of a toss of a coin. When you toss a coin, it either give you head or tail. It will not give you both. Okay. So if someone say that head is appears when the coin fallen down, so it means that tail is not going to appear. Okay. So that what exactly the mutually exclusive event means. If some one event happens, another event that makes sure that another event will not happen. Okay. Same when you throw the die, either if one is occur in that event or the experiment, it means other five will not occur. Okay. So that what basically a mutually exclusive event called. Okay. Okay. So example, coin toss given either head or tail, not both, it will give it to you. So that is example. Now probability of A intersection B. So what exactly so this sign means intersection sign, and this is when the head is above, it's called to be the union sign, and when the head is below, it's called to be the intersection sign. Intersection sign means what is the common between both the events. So right now here two events happens. If some two events will happen, what's the common between them? So right now I'm saying one event is head and another event is tail. Okay. So what is the common between the head and tail? So there is nothing common between head and tail when this event is happening. So the intersection is zero. Intersection means what's the common between whatever the possible outcomes. Then here A union B formula is A probability of A probability of B plus probability of A intersection B. So A is in mutually exclusive, intersection is zero. That's why your final answer will become probability of A plus probability of B. So whenever someone will mention the word mutually exclusive and find the probability for that, so just remind in that case that means twist means tricking you, or they are asking some kind of questions means tricky question to it because their probability means probability of A intersection B is zero. So don't forget that. Next one, we talked about mutual exclusive. We are talking next about independent event. So we already talked about independent variables in our first lecture, means first and second session. So I'm not dependent upon you. So that's what exactly the independent. So if you throw your coin and if you throw your dice, so if one appears on the die and you do means if one appears on the dice and if you throw the coin, it might appear head or tail. Okay, both events are independent of each other. So if you throw right, it doesn't have any effect on your coin. So that is called to be the two event called to be the independent event. So two events are independent if occurrence of one has no influence on the other. So here occurrence of one has influence on the other. Explain more about mutually exclusive event. Okay, so mutually exclusive event basically. Okay, I'm explaining the same only. Well will be. So so let's assume here we have the two events. Okay, okay. So one event is you are tossing some coin. Okay, and another event is you are tossing some die. Okay, so these are the two events. Okay, now when you toss a coin, head appears. Okay, and when you toss a die, so initially head appears. When you toss again a die, it will give you one, two, three. So these two things are not dependent. Means either it will be head or tail. It's not that event is not dependent on this event. Okay. Uh, let's uh, let's take independent event events. I think a real life example of today's event. Okay. Means real life means I will tell you the example of an independent event. Okay. So let's assume that today there is a delay of flight in Chennai from Delhi. Okay. So I'm living in Chennai. So there is a flight delay by around 4 hours, which is means take over from Delhi and land here by means there is a delay of 4 hours. Okay, and I want to sleep in the night before 10 o'clock. Okay, so these two events are totally different. Means independence. Okay, there is no dependence. Means even if the flight coming early or coming late, that is another event. Okay. But means and my sleep time is not dependent upon that event. Okay, so that is two independent event. Okay, now let's assume that I want to means I want to what you can say I want to receive someone else. Okay, I want to pay means I want to receive some kind of a guest from the airport. In that case, I think that event is dependent because for flight is late, then you will there is a delay in the flight, and then you will receive that person. So there is a delay in your whole schedule, and then you will sleep late. So that's what basically a mutually exclusive and independent and dependent event. So I think hope you understand the concept. So in this case, the probability of A intersection B means the probability of A intersection means two events are if they are independent, then you are going to multiply this probability of A and B. So that's how this probability of A union B becomes this probability of A plus probability of B is equal to probability of A multiplied by B. So these are basic formulas. So just to write the formula we are going to see next. Okay, so before going to the numerical, I will show you what exactly with the help of figure, what exactly A union B and all those. So let's assume we have two events. So this is all our sample space. Okay. This is the possible combinations can appear here. E. So right now this whole I am explaining with the help of area. So this is my area where all the things can happen. So this is my event E. So and this is my event F. These are the two events. Now, when I'm talking about A in union F means I'm talking about all which is common between E and means all which is comes under E and F. That's what I am talking about A union B means. So this yellow portion is representing here. So whatever the region coming under E and F, that is called to be the A union F. Okay. Now someone told that what is E intersection F. So E intersection is what is common between E and F. Okay. Here I'm talking about what comes under E and F and what is common between E and F. So that what is represented with the help of intersection. Okay. So that is E and F. Okay. Then when someone will say E complement, so this is race means superscript C represents the complement to particular event. So someone will say that complement of event E. So means you have the event E other than all things are called to be the complement of E. So here yellow portion I represented here. So this is my event E. E complements all other than E is my complement. Moving towards next, this is the subset that F is the subset of event E. So means F is the means E is the subset of whole F, and within E there is F. That's why E is the subset. So this is the subset sign given over here. So that is basically a Venn diagram, and that's how the probability and all the things work. Moving towards the question. So if two events A and B are mutually exclusive, hmm, what can be said about their intersection? Two events are mutually exclusive. Means if one happens, another will not happen. What you can say about the intersection? So just we talked on that itself. I already explained during that. So most of you answering as A, the intersection of A and B is the empty set. Okay. So moving towards answer, you are all are correct. So we already talked that probability of A intersection B will give you the zero means there is nothing else is there. So that's what we discussed. Nothing means that's an empty set. You are not going to get anything. Okay. So mutually exclusive event has no common outcomes such as coin toss and die rolling. So the intersection between two mutually exclusive events. So this is the wrong example. I think toss of a coin that should be there. Okay. I will make changes in the PPT. Another question, if event A and B are independent, right now here events are independent, Which of the following is true about their joint probability? So yeah, you all are correct. So correct answer is A multiplied by probability of A multiplied by B. That is the correct answer when I'm talking about the joint probability. Okay, so hope these are just a formula, mutually exclusive and independent event. So when mutually exclusive event intersection is zero, mutual independent event when you have the kind of multiplication of those probability. So that you have to be sure about that. Next question: are mutually exclusive event always dependent? B, okay, A, B, yes. Okay, so more two of you answered the B. So let's understand the reason. Mutually exclusive events cannot happen together. Okay, if one event occurs, it eliminates the possibility of other event occurring. Okay, so are mutually exclusive event always dependent? Yes, they are always dependent. Okay, so that's what exactly that explanation on this. Now, if event A and B are independent and probability of A is given to probability of B is given to then probability of A union B. What is the probability of A union B? A and B are independent right now. So just go through that formula. Probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. And then this is the independent event. So you know that what is the probability of A union A intersection B. That way you can calculate. So few of you answering as B, A. Okay, it's a mix of answers. Mhm. Let's wait for the other. Someone answer to the D. Okay. Mm, So go to our statements. When it's an independent, what happens? Probability of A multiplied by B that is going to happen. Okay. So this is the formula. I think means someone might add this particular sign, so you will get probability which is greater than one. So that is not possible. So here is the formula: probability of A plus probability of B. So here probability of means 0.4, 0.6, it become 1, and this is 0.4 multiplied by 6. So that way you can subtract it and it will give you the answer 0.76. So mutually exclusive event always dependent. Okay. Okay. So, what exactly I mean here means first one. So if you are a mutually exclusive event means if something is occurring, another will not occur. Okay. So they are always means what exactly dependent means. I am dependent on someone else. Okay. Okay, uh, so here when we have the coin, I toss the coin. Okay, if head appears, okay, that is the example of mutually exclusive event. Head appears, you will not get the tail. Okay, so right now, um, if head appears, so that is one event, and tail appears, that is another event. Will the recording available? Yeah, recording will be available. Yeah. So this means if some event will happen, a mutual exclusive if some event happen, another will not happen. So that event happen means it has a strong dependence on the happening of the another event. So that's why they are dependent. If A will means it's like if A will happen, B will not happen. That means they are dependent on each other. Means so that I'm not able to find example. If someone have any example in their mind, they can just put in the chat box. I think that will help the Lokesh to understand what exactly I mean. Okay, moving towards our conditional probability. So here conditional probability means something. Okay, we'll go to the definition and then again we will discuss on that. So if two events A and B are not independent. So initially we talked about dependent events. Right now we are talking about independent event. Okay. Then information available about the outcome of A can influence the predictability of event B. Okay. If someone has effect on the means if some event happens, so if there is some influence on the predictability of B, so that probability will be calculated with the help of this formula. So probability of B. So how you should read this? This is read as probability of B. Now you want to find a probability of B given event A is already happened. Okay, is equals to how you calculate probability of A intersection B divided by probability of A. So that's what exactly it means. Okay. So the example of this, with the help of simple example, two fair coins are tossed. Okay. So I have two coins in my two hands. I will toss both of them. Okay. So you know that you the possible combination, you will get the four combination. First event. Okay. First toss is head. So right now in this event, we are considering your first toss means first coin should you will give you head. So what are the possible combinations out of it? So head tail and head are the combination. Event B is telling two successive head. So that is head and head. So probability of event A and B will calculate. So that is 2 by 4 and 1 by 4 0.5 and 0.25. Okay. If the event A is given, then probability of event B is. So right now, if someone told that event A is given to you, okay, that head is going to be appear in the first event, then what is the probability of getting B? Okay, so here event A is already happened, means in the event A, what means first toss is head. Means you know that first toss is always head. In the second event, there is a two heads. Means already one event you know, okay, what's the effect on of that event on the another event. So here how we calculate probability of A intersection B, that is 0.25, and then probability of A, that is 0.5, that gives you 0.5 with the correct answer. Okay. So why this is affecting your another event? So if you just considering event B, which is you're just considering only event B, so what is the probability of getting head head? It's by 1 by 4, means you will get, means you are going to get out of four combination, you will get only one combination, that is head head out of all possible four combination. But someone told that you already, means there is a event one happen, and that event is nothing but a head will be there. Okay, first head will be there. So you know that already there is a head. So I just want to flip my second coin. And flipping second coin is nothing but a 0.5 probability. Okay, so that's how it is easier to get. So just go through different examples. So I just explained you the one example. There are so many train examples and all. So you go through that example, you will understand this conditional probability. And based upon this conditional probability, there is a Bayes theorem comes into the play. How the value 0.5 in the intersection of A and B? Explain please. Okay. So intersection of A and B. So right now, intersection of A union B means what? Okay. Uh, so probably, okay, let me check once. Mm, Okay, sorry. So, yeah, thank you for correcting me. So, this probability should not be 0.25. So, we have to check between the what is the intersection between the event A and B. So, I think I just mistakenly put this value 0.25 here. So, it should not be 0.25. So, it might be like means you have to take a common between them. So, I think head is common. So, that's why it becomes okay. Okay, sorry. Okay, so I think it's right. So one, what is common between the event A and B? So common is HH is the common, and all my sample space what I have is 4. So 1 by 4 is 0.2. So it's correct only. Yeah. So what is between common between A and B? That is means HH is common, and whole I'm talking about whole sample space. So whole sample space I have, there are four possible combination: head tail head, and tail. So that's why here one common thing and divided by all four possible combinations. So that's why the 0.25 probability, it's 1 by 4. So this is also correct. Yeah. So thanks for means again explaining it. Okay. So moving towards next one. If event A and B are independent, which of the following is true about their conditional probability? So if event A and B are independent, so right now we know this formula, probability of B given A. So probability A intersection B, you know what's going to happen with the so moving towards answer, it's probability of the answer is probability of A is the correct answer. So for independent event A and B, the occurrence of event B does not affect the probability of event B. So here A intersection B in the independent event case we already saw, it's just a multiplication of both probability A and probability B. And then this is probability. So probability of B, B cancel, and then we will left with the probability of A. Okay. So for independent event A and B, the occurrence of event B does not affect the probability of event A. So if if both events are independent, then one event will not cause any effect on the another event, such as coin toss and the dice. Okay. So these are basically just understand this statement, and there are a few formulas. So just you have to put the values in those formulas and you will get the answers. Another thing, so this is kind of a common questions in the probability subject asked. So if a group of people, 40% likes ice cream, 30% like chocolate, and 20% like both. So both means it's an intersection between ice cream and the chocolate. Okay, what is the probability that a randomly selected person likes ice cream with that they like chocolate? Okay, so what is the probability that a randomly selected person likes ice cream given that they like chocolate? So this is the conditional probability statement. So yeah, okay, side. Okay, Lucas answered as a B. Okay, so this is the conditional statement again, conditional probability statement. If I tell that okay, select a person likes ice cream, given that if someone likes chocolate, what is the probability that they also can like the ice cream? So uh, this kind of question generally asked during the kind of when you do the data analytics and all. So if someone if it's like what is the probability if someone purchased the laptop on the digital marketplace? So what is the probability he will also purchase the laptop bag? So that is the first event, purchasing the laptop, and another event is purchasing the laptop bag also. So that way you have to give the analytics. So this is conditional probability will work in those cases. Okay. So moving towards answer, the correct answer is B. So here you can see I gave I and C to represent the event. Someone likes ice cream with 0. So 40% means 0.4 probability, 0.3, and this is the intersection 0.2. Now randomly selected person likes ice cream given, so he likes ice cream that given C. Okay, so whatever the given event, so you have to just put that in the denominator. Okay, so probability of C intersection B, you already have 0.2 and 0.3. So it's a 2 by 3, and that's why your answer is B. Okay, so these are very helpful concept in the mathematics term, which generally we utilize, but we don't know we are utilizing in our backend. It's going on, but you don't know that you are utilizing this terminology. So when you say that what is the use of maths in our day-to-day life, we learn about sine, cos, theta. You are utilizing that all those stuff you learn, but you don't know in your backend how you are utilizing those. So there is a uh, importance of math in your daily life. So moving towards our random variable. Right now, we talked about random phenomena, probability, and all. So whatever the outcomes coming out of it. So right now I'm coming 1, 2, 3, 4, 5, 6, and another thing is I'm getting head and tail. So if I want to convert them into the mathematical, because when you want to do some kind of a mathematical calculation or mathematical formula building, all those things, so in those case, there is a you have okay. So are we having problem? So right now I not took any problem related to A subscript C means A to the complement C. So in this case it's not there, but you can go on internet Kamachi and you will get all those kind of question. So she is talking about A complement C kind of question. So I think that is not covered in the exercise also. So I not took that kind of example, but you can look into the on the internet, and those are available there. Okay, so here I'm talking about random variable. So random variable is a map from sample space to real line. So I want to go into the real line that there is a unique real number corresponding to each outcome. So kind when you toss a coin, it's a head and tail. So when you want to do maths, you should always convert into the binary term. So it will become easier for the computer explain the random variable. So yeah, so very basic term. You have some outcomes. So head, tail, that is one of the outcomes you have. Now you want to apply some maths on it, or you want to feed it into the computer program. So it's better to have a numeric concept. You should have the number. So that's what exactly the random variable means. Whatever the outcomes you are getting, you want to convert them. Those outcomes is nothing but a variable, and we are converting them into the mathematics formula. So that's what exactly called to be the random variables. Random phenomena will give you some random outputs, and converting those random outputs in number format, it's basically a random variable. Okay. So here I'm converting head and tail. Those are four possible options. Map into the 0 and 1. 0 I will represent it as a head and tail. In Dias case, you already have those number 1, 2, 3, 4, 5, 6. So you can represent that with the help of that. Now there are two kinds of random variables. Okay. So first one, random variable means whenever you throw a die, that is one of the case, and the coin toss we saw those two cases. Okay. We are going to see there are continuous space as well. One is the discrete space. Discrete space means specific number, specific integer associated with that. And continuous space means you have the continuous number where you have the float values. Float value means the decimal value. So discrete random variable, a variable that takes one value from a discrete set of variables. So Dial's example 1, 2, 3, 4, 5, 6. Or you can say rank of a JE when you give the JE engineering exam or NEET exam. What's the rank of the particular person? So it will give you one integer value. So that is called to be the discrete value. Your rank cannot be 1.2 or 1.3. So that's what exactly the difference between the discrete and the continuous. Continuous space means you will have the continuous means decimal values as well, a variable that can take a continuous range of variables. So temperature of the week. So you will say 28. Generally, for approximation, you will say today's temperature is 28. But it's not exactly 28. It's a 28.3, 21.0, or 25.9 like that. So that's whatever the random variable you have. So those random variable can be classified into two groups. One which is discrete when you just have the integers, and one with the decimals you will where you have the decimal values as well. So that's what basic difference between the discrete and the continuous random variable. So we will go some examples here. Okay, that I think if you understand what discrete and all, so that will help you to solve this. Which of the following is the example of discrete random variable? So I gave different cases. So which one of this is the discrete random variable, or you can say the discrete phenomena? Okay, so many of you answering it as a C after reading it. So you all are correct. Correct answer is C. So let's see why it's the correct answer. Because when you throw your coin, you will get either head or tail, and we can convert that into the 0 1 form. So 0 and 1. Talking about other means options, height of an individual. So you will say 4.5. I'm 4.4 inch or 4.5. So decimal is coming there. Temperature, we already saw the example. Time taken to complete the marathon. There is a fraction of seconds. So someone completed 9.1, 9.2, 9.9. So that's 100-minute race where Usain Bolt with zero point 0.0 decimal seconds he is lost the race. So all the decimal things are coming. So all these are continuous example. So only example where is head and tail is the mm, discrete example. Which is moving towards another. So that is what exactly the explanation behind discrete and random. Moving towards next question, the probability distribution of discrete random variable must satisfy which of the following condition? So these are the different options. You can give your answer. So we already talked about the means probability condition. So I think probability distribution of discrete random variable which satisfy which of the following condition. So you answer it as a B, most of you. Uh, so someone answer it as a D. So probability will not be integer. Your outcomes, whatever the outcomes you are getting, that should be integer, not your probability. Okay, because you saw probability in when we saw that even number appearance of even number. So 2 4 6 is these are the three possible combination divided by that 6, all 1 to 6, so it's become 3 by 6. So you are getting some 0.5 value. That's the decimal value you are getting. So the correct answer is the sum of probability must be exactly one. That is the case while discussing on that. Okay. So that is what exactly the explanation. It should not be the D, the probability must be integer. So probability means how many value in if you consider between, so probability always between 0 and 1. And if you are talking that the probability must be integer, So you just have the one value and zero value. That's that only two integer you have. So you will get either zero or one, and their range is between zero and one. So the whole probability concept will going to collapse. Okay. Moving towards next, now if you want to calculate the probability during this, so initially we saw a particular kind of very basic examples where we are just calculating the particular event 1 2 3 4 like that, and based upon that we are calculating the probability. But in real life the probability means when there are multiple kind of outputs are there, in that case we have to go through these particular formulas. So first formula is meant for the probability discrete values and another for the continuous values. So probability, mass, or density. So this is called to be the mass function for the discrete thing, and this is called to be the density function. Help to assign probability to every outcome of a sample space. So these are just a kind of advanced version what we talked about the probability in terms of the mathematics. Okay, so here example I gave you. So this is the way you generally represents the probability of event. This is the mathematical notation probability of event x. Okay, so probability of this particular x, capital X generally we wrote, is equals to this particular outcome is going to be happen. So x is the in coin toss means what is the probability of getting head or tail. So is it week three? Yeah, it's a week three session. Yeah. So probability of X means outcome of getting zero. Here, I mean zero means head and tail means one. So probability of getting zero is 0.5. Probability getting tail is one. So that's how your probability is 0.5 and 0.5. So you already know head and tail probability. So that's how you can represent this with the help of this particular formula. So now moving okay, give me a minute. I think let me rejoin with my. Uh, give me a minute. I'm joining with my another device. Okay. Uh, give me a minute. There is some problem with my mobile, so that I can get the query from a thing. Um, Okay, so okay. Sorry for the disturbance. We'll move forward. Uh, okay, so we already talked about the mass function. Okay. Um, Hmm. Now we are going to talk about the density function. Okay. So density function is basically meant for the means here you are able to calculate the outcomes means zero means head or tail like that. But here it becomes very complex thing. Okay. Where you have the point value 0.1, 0.2, all if you want to take the height of an Indian man and all, and you want to calculate the probability of getting height means greater than zero means 5 inch or something like that. So there is a spectrum of range. So whenever there is a spectrum of range comes, okay, in that case, um, okay. So whenever there is a spectrum of range comes, in that case, we generally use the integration. Okay, to calculate this. So this is the particular function for that, and we are going to integrate this. So this is the particular function when you will put x, and based upon that function, you will have the some limit, okay, and then based upon that limit you will get the out. So here I gave the example height between between 20 and 40. Okay. So in the, okay, so this is the height between a 20 and 40. So this is particular function to calculate the height. Okay. And this is 20 and this is 40. And based upon that, you will get the particular output, and that integration, whatever the output you are getting, that will give you the probability. So that is basically this we will understand with the help of the examples more better way. Uh, okay. So moving towards our next question. So this is similar question asked, I think. Uh, yeah, I mean, it's depend how you represent small f of x. So I think it's a mathematical notation. So small f of x is the correct, I think, mathematical notation. Yeah, thanks for the correction. Um, so moving towards the question, this is question kind of questions generally I think asked defective and non-defective pieces in the exam. Uh, the box contains 20 defective items. Okay, right now we have the box. 80 non-defective items it has. If two items are selected at random without replacement, what will be the probability that both items are defective? So this example, I think one that ball example which we saw, you can solve this example that way itself. So in this case, we have defective non-defective. In that case, we had the red and blue balls. Okay. So the box contains 20 defective items and 80 non-defective. Means you have total sample space is 100, because non-defective and defective combines together, it becomes 100. If two items are selected at random without replacement, so we are selecting one, and then another we are selecting second item. So what is the probability of that both items are defective? So just take pen and paper and just draw that kind of a diagram, tree diagram, and then with the help of that you can get the answer very easily. So Lokesh answer it as a D. Okay. We'll wait for the others answer, and then we will proceed with the explanation. Okay, Suchita answer D, Prakash, Ranjan D. Okay, most of you answering as a D. Let's go to the explanation. Correct answer is D. So, very basic, simple thing. I have 100 pieces. Out of which 20 are defective and 80 are non-defective. What they asked me, they asked me what is the probability of both getting both items are defective. And another important thing, without replacement. I'm not going to again put that inside the box. So when I take one out, I will end up with 99. Okay. So first of getting defective is 20. So 20 by 100. So when I first remove, the probability becomes 20 by 100. Now I remain with 99. Again, how many one if I remove one defective item, so you will remain as 19 defective, and 18 non-defective remain as it is. So right now, again, I will do kind of probability thing. So right now I'm on 99 things from which I can choose 19 things. So it becomes 19 by 99. And that's how you will multiply both of them, and you will get the probability, combined probability, that is 19 by 495. So, when such kind of question are, just follow this three example. Very basics, and you will never get, means you will never fail to answer the question. Okay. And there no need to mug up the formula and all. So from that tree diagram, you can easily answer. Next, we are going to move. There are some distributions and all. For distribution means when you are going to, here we talked about different experiment, kind of hair, tail, and all. So distribution is basically when you are drawing something. Okay. Let's consider you are conducting the experiment in your laboratory of a chemistry department. So you are going to take different samples from it. Okay, and then you collect those samples and you draw a particular histogram. Okay, what exactly histogram means? How many particular values are within specific range, and then you draw that particular histogram. That particular histogram has particular kind of a shape, and that particular shape, or that particular uh, that whatever the particular shape is coming out of it, that represent a particular distribution. So you generally, whenever you are generating the data, okay, from the experiments of the lab, or let's understand this with the help of, I don't know how many you did the experiment, but we will I think you will understand this with the help of a simple example. You someone gave you the job and you want to find the heights of a Indian population. So you go to the different state and you collected the heights. Okay. So when you collected the heights, then what you are going to do? You are going to make a bins. So how many people are between the range 0 to 10 means 0 to 1 food, 1 to 2 food, 3 to means 2 to 3 food, and like that till around 7 to 8 food. I think that's exactly the average height of an Indian man, 7 to 8 foot. So when you form such kind of bins and when you uh, when you plot all those things, okay, so you will end up with particular kind of bell-shaped curve. Okay, so the height of a human being, it comes from the normal distribution. Okay, so normal distribution has, there is a two distribution. That two distribution means you have some machine from which you are getting, you give some value, new mean and standard deviation. So with the help of that particular values or the parameter, you are getting some outputs out of it. So in case of a in case of height also, there is a some hidden some parameter. Okay, when you take the experiment and when you combine all those data, you will get particular spectrum out of it, and that what exactly the distribution means. So here I gave the example. Let's understand this with the help of this example. So I'm having right now a particular coin which I'm going to toss. Okay, so uh, this particular kind of where you are getting two outcomes. Such kind of a distributions are called to be the binomial distributions. Okay, bi means two. Right now I'm having a coin which is kind of a biased coin. Okay, so what I'm going to do, so flip, I'm going to flip that coin. I will flip once, I will flip two, I will flip three, and I will check what is the probability of getting a particular head. Okay, so so here you are able, I think I will go back, and here you are able to see, here I'm doing the flips, I'm calculating the probability, and when I calculate it till 500 times, so my probability getting reach, probability of getting head reach to 0.2, and head of bias means your heads are biased, and that's why your probability is 0.2. It not reach to 0.5 because when you toss your coin, it always be the 0.5. Okay, when you do the multiple toss. So that example I will show you with the help of animation in the next slide. So this is the binomial particular probability particular formula. So we will not go in depth of this because this is a bit complex, and for each distribution there are the formula. Okay, moving towards next, this is the normal distribution. So normal distribution is the very common distribution. Whenever you do some experiment, whatever the natural things happening in the environment, those are mostly follows the natural means this particular distribution, standard is normal distribution. So this is called to be normal distribution, which is a Gaussian distribution. In this case, when you your mean is particular this thing. Okay, lie at the center in the Gaussian distribution, and your data lie. This is standard distribution means how much data away from my particular. Generally, variance or standard distribution help you to know how much your data is spread. So if you calculate this standard distribution, so when your data is coming from the Gaussian distribution, so your first standard deviation will cover around 68.27%. Second standard deviation will cover around 95% of the data, and 99.73% of the data comes under 99.7, and this is sigma. Okay, so I don't know how many of you coming from the industry. So when they talked about Six Sigma, okay, Six Sigma belt or something like that, so they are referring to this particular standard, particular sigmas. Okay, when you go through Six Sigma, so right now I'm going to one sigma, two sigma, three sigma. When you go to Six Sigma, so till that time it becomes 99.99999. So when some industry, I think in safety and all, they are talking about Six Sigma. This company attend the certification of Six Sigma. That means throughout this number of this many number of days, there is no any near miss, means there is no any accident or near miss happen in their industry, and that's why they got the particular certification. That will help you to give the trust to your consumer or the customer or your stockholder that our industry is very safe, and because we receive a particular certification, that is the Six Sigma certification. So that Six Sigma is nothing but this particular sigmas. How many accidents not happen? This many of the events happen, but nothing is there in the accident. Okay, so that's what exactly the Six Sigma and all mean. So this is a particular formula where parameters you can say mu, and this mean and the standard deviation value represents the parameter of this particular Gaussian distribution. So chi-cast distribution is the another distribution. Function is characterized by one parameter, that is degree of freedom. So there are different kind of distribution, means in the environment, data which is generated if you perform an experiment, if you take sample, if you take voting from the person, people, I mean, if you take the suggestion from the people to whom they are going to vote. So all these are called to be, when you combine those data, it is coming from some kind of a distribution. So one of them is the chi-square distribution. This helps us in the hypothesis testing. We will see in depth how this is going to be held. So this is one additional kind of, you can say, a distribution. Now we will go and see some numericals on that. So what type of event does the binomial distribution model? So we saw the binomial distribution, which kind of event they generally model. Continuous discrete event with normal distribution, event with no uniform distribution. So yeah, Prakash answered, Venkatesh, Suchita. Yeah, you all are correct. Discrete event. They are handling binomial, means they are going to handle bi, means two outcomes. So two outcomes are happening in the, you can see the example of a head and tail. So that's exactly the discrete event. So that's why correct answer is B. So next one, what is the shape of Gaussian distribution? So just we saw whatever the shape I saw, which shape we saw here. So this is the kind of a Gaussian distribution. And when its mean is zero and standard deviation is one, that is called to be the normal standard deviation. Okay. So what is the shape of this? U shape, skewed shape, bell shape, skewed to the right. Skewed means it will tilt to some on the left hand side or the right hand side. So someone answered C's and Satya answered as A. So correct answer for it, it's a bell shape. You are able to see the bell curve. It's not a U. I think U is like this. So it's, if you flip the U, it becomes a bell. So it's a bell shape, not a U shape. You can say it as a inverse U kind of shape like that. Okay. So here you can see this. This is how U represents, not like this. So correct answer is it's a bell shape. So you can see here bell, and you can bring that kind of thing. Okay. So what are the parameters that defines a chi-square distribution? We already saw parameters. Mean and standard deviation are represented means in the Gaussian distribution. So similarly in chi-square distribution, which one is the parameter? Okay, so yeah. So Prakash, Hemalata. So you are all are correct. So answer is degree of freedom is the one of the parameter. So here K is generally they utilize parameter for this particular distribution. So if you have K, then you can generate the this distribution. If you have mean and standard deviation, then you can generate the standard, I mean, normal distribution. Okay, Gaussian distribution. So generally, when you are talking about random number generation in your, when you are writing code and you want to generate some random samples, random numbers. So in that case, if you want to generate Gaussian distribution, so you will give mean value and the standard deviation value, and that will help you to generate the random numbers in mathematical programming. Moving towards next question, what percentage of data falls within one standard deviation of mean in a normal distribution? So I'm talking about normal distribution. So how much data comes under when one standard normal? So I already talked on that. So I think you all are heard correct. It's 68% in comes under one normal distribution. And this is, you can say. So this is just absolute 68, 95, 99%. So this kind of question I might ask how many standard deviation and all. Now we are talking about the expected value. So let's read this. It's a way to understand what might happen on average if you repeat something many times. Okay. So what this probability, how this probability concept comes. So we are saying that probability of getting hit is 0.5. So uh, first you flip, it becomes head, tail, head, tail. Now, if you perform this experiment very too much, means very for a very long time, so what kind of probability you will get? Okay. So here is the experiment shown over here. I don't know how clear visible to you. So I will explain. So this is left hand side y-axis showing the probability of head. This is number of times you are flipping the coin and calculating that probability. So here there are around five people who conducted. Here I think you can consider 10 people conducted the experiment. I gave this particular coin to 10 people, and I told them just flip this till 500 times and see what's the probability you will get. So here you can see we have the 10 experiment and we want to calculate the probability of it. So initially you can say here it's going up and down. So someone got tail in the initial case. So with the help of one particular his particular flipping, he is getting tail. So that's why the probability of getting tail, getting head is becomes zero. Then he flip two. Then he flip means then he flip again. So he might get head or tail. He flipped again. So when he flipped till 500, so you are going to see the probability of getting head is reaching towards the 0.5. Okay. Similarly, for every experiment, I gave coin to all 10 people. And here, from all 10 experiment, you can see this particular, it started with somewhere from here because you don't know in the initial stage you are getting head or tail. But when you repeat this experiment till 500, you are getting probability 0.1. So that what exactly kind of expected value it's all about. When you are going to perform some experiment again and again, you will attain a particular value that is called to be the expected value. So you are getting expected value here 0.5. If coin is tossed, probability of getting hit. So this is the example I shown here. So for discrete distribution, so how you calculated the expected value? It's your particular event multiplied by that probability of getting that event, and so you will do summation of all those events which is going to be happening. In continuous probability, you will just multiply that particular event with the particular function, and you will do the you will integrate all those things. So this is the basically formula of the expected value. I don't know how much I'm able to explain you the expected value. So it's sometimes it's become very kind of very hard to digest this terminology. So for your examination right now, just understand this formula, and then with the different example you can understand the expected value. Go on the internet and try with different examples. Okay, so the continuous distribution, and these are different distributions. So now when you talk about the Gaussian distribution and all, so expected value of getting means this particular event is reached to mean value. So when you perform particular experiment again and again, so expected value means you want to reach to the actual parameter of your distribution. Okay, right now you are performing some experiment, and that experiment set on particular mean and standard deviation. So you will get some value, another value, third value. So when you perform that experiment for infinite time, and when you calculate the expected value of that, you will reach the actual true mean of that value. Okay, so that's a true mean, and then when you calculate, this is the expected value we are calculating. So similarly for variance, so if you want to calculate variance, so expected value of the means this is x minus mu square is nothing but the standard deviation. Okay, so expected value means you are performing any experiment again and again, and you want you will reach a particular value. So that's what exactly expected value means. It's a way to understand what might happen on average if you repeat something many times. Okay, so this is the kind of example of expected value. Here I'm flipping the coin. Okay, someone will tell that okay, probability is 0.5. Okay, that concept is there. Okay, now I want to prove that concept. So first you will toss your coin, you will get head. Again you will toss coin, you will get tail. So every time when you increase that event and you are calculating probability for that number of times of the flipping your coin, you will end up at the end that you will either get head or tail from this 500 times he flip the coins. Out of this till I think 250 coins he will get means out of this 500 toss he will get around near to 250 or 240, 260 like that. He will get the values which are tails and head. Okay, so that's what exactly the expected value tells about. Okay, it's a way of means understanding what might happen on average. So so if you want to know the true probability, true experiment, so when you go to the casinos and all, so if you go to the Las Vegas or the Goa and all, when you enter to the casinos, so if you want to know what's from which distribution these numbers are coming, so those random numbers generated in the slot, I mean that machine, slotting machine where you just pull the lever and some numbers are coming. Okay, So there is a some pattern or mathematics behind coming those numbers 1 1 1 2 2 2 3 3 3 like that. So someone set that numbers, okay, and now you want to win the lottery, okay. So you are going to means you are going to pull that lever and some means something will appear. So if you do thousands and hundreds of times, so you will come across some parameters of that, okay. So someone said that two parameters. We don't know what exactly those two parameters. Okay, someone from their technical team said that parameter, and based upon that, outputs are coming on your slotting machine. Now you went there on the casino, and you are pulling that slotting machine because here you don't know what parameter that outputs are coming or showing to you. Okay, so that's the example of slotting machine. But in real life example, when you calculate the height of a particular person, okay, in that case, you don't know what exactly for the Indian means what exactly the mean and the standard deviation. So it's a bell-shaped curve you will get generally when you calculate the population. So you don't know what exactly the mean and standard deviation said by a god. I don't know whether you follow God or some God or you atheist. I don't know. So who is sitting there or the nature? What's exactly the mean and standard deviation value said by the nature for Indian subcontinent? You don't know that value. So in that case, we will sample thousands of people and we will calculate and we will see, we will draw the graphs and all. And based upon that, we will say this is coming from the normal distribution. So when you calculate this expected value, okay, by performing different experiment, you are trying to reach the true means. So in that sorting machine, there is a true means which is set by someone, but in nature, you don't know what exactly the true mean. So if you perform that experiment infinite times, you are trying to reach to that true mean, and that's how we are design our systems in the mechanical engineering department or the chemical engineering department or the instrumentation. Okay, that's how the mathematical modeling and all has been done. Moving towards our questions, if you roll a fair die, six-sided die, what is the expected value of a single roll? So here we will see what how to calculate expected value. What is the probability expected value of single roll? So expected value I am asking here. Okay, location of the C. So I will tell you why answer is 3.5 here. Okay. So the formula is as follows. So this is X, whatever your outcome. Okay. So 1, 2, 3, 4, 5, those are all your outcome. Probability of getting that outcome. Here, probability is 1 by, you will get 1 from 1 to 6 possible combinations. So it becomes 1 by 6. So right now, I'm asking what is the expected value of single roll. Okay, so it's 1 multiplied by 1 by 6. For all this number, you are getting probability 1 by 6. So when you combine all those things, you will get 7 by 10. That's why the answer is 3.5. So the correct answer is not 6. It's 3.5 is the expected value. So expected value range can be greater than 1, that you should know. Okay. When they ask about the probability, only then it's value between 0 and 1. Okay. So here the expected value is 3.5. Okay. Moving towards the next, in a normal Gaussian distribution, where is the expected value located? Okay, it's a C, the mean of the distribution. Okay, Saita Venkatesh. Yeah, you all are correct. It's the mean. So I just gave the example of height and other experiments and all. So yeah, you are correct. It's reach or it's at the center of it's at the center of the whole Gaussian distribution, and that is nothing but a mean value. So we will go through the some properties. These are the properties of expected value, variance, and the mean. Okay, so uh, just write those formula and how I don't know how they come, how they derive. So we will see this formula and we will solve. I think 2 to 3 questions are asked on that. So just take a snapshot. I think that will be helpful by looking at this formula. So expected value of this particular is the linear combination A multiplied by x1 plus b. This is kind of a linear combination, or you can say the linear equation. Now I want to calculate the expected value of that particular linear equation. So very simple. First, you take out this A out and then calculate the expected value of this variable. So x1 is our variable here. Okay. And then you have the B. So B, A and B are the constant here. So just keep the constant out while calculating the expected value. Okay. And then expected value of this whole equation, ax1 plus bx2. So again, I'm calculating that I'm taking out A out and then expected value of x1 plus B out, expected value of x1. So this is all about expectation. What about variance? So someone called me and talked about what is the variance of this particular combination. So when they talk about variance, you should do the square of the constant. Okay. Square of those constant where your variable is assumed, where your variable is present. So here your variable is present, vx1. But with respect to b, variable is not present. So it will become 0. So a square v of x1. When there are two, means it's a two combination of two variables. So in that case, it's simple like a kind of a equation. So it's like a square v of x1 plus b square v of x2 plus 2ab convergence of x1 and x2. Okay. That's what exactly. Okay, so sorry, so yeah. So Veljit, yeah, you corrected me. So here in the formula, I think so this should be x2, not x1. So thanks for correction. But I think you get the concept. I think, yeah, right. So getting concept is important. So this is x1 b square. So uh, in expectation, okay, what is the sorry, this is not a convergence. This is the covariance between the x1 and x2. So I will tell the covariance and correlation in the next slide. So for that, for right now, we are going to solve this numerical in the next slide. So just take a snapshot and have with you. We will move towards the next. So if variance of x is 9 and variance of y is 16, what is the variance of this is right now your two variables x and y. Based upon that, here you have the equation 2x minus 3y. If x and y are independent, so what exactly the particular answer for this? What is the variance of 2x minus 3y? So just go through that formula and you can calculate. So these are the formula. Just put the I think okay 2x plus 3y. I think I give the variance. This is the formula. I think. Okay, so most important thing, the way question is twisted here. Here I told that x and y are independent. Okay, so that is kind of a twist here. So answer is 180. I think two of you who knows a bit mathematics and have the background of mathematics, they are able to solve this. Covariance means what exactly means? Is there any relationship between the x and y? That what exactly means? In simple words, a covariance. Um, so if the two events are independent, so means there is no any relation between x and y. In that case, this becomes zero covariance between x and y. So that's why this becomes zero. And if this becomes zero, you already have these values. So you will just square this one and then put this value and then this three and all, and then you will calculate. So you will get the answer 180. So such kind of twist they will give in the exams, and you will means you will be like they not give means you will think that this is the formula should be applied there but they not give the 2ab plus convergence and all this. So this question is wrong, but this question is not wrong. They just gave one statement that will solve you the query. Okay, so that's why it's important to know independent, dependent, mutually exclusive, all those events and all. Moving towards next question. So let x and y be two independent random variables with expectation 5 and expectation 3. What is the expectation of random variable this 2x plus 3y? So I think again that's simple formula. Okay, B, correct, sir. Okay, okay, Prakash. So yeah, so the correct answer is B, and that's a one. So those who are not able to answer, it's a simple formula. Just I will keep out A, B, and then just I will do the multiplication. So this is 2 multiplied by expectation 5, 2 multiplied by 5 minus 3 multiplied by 3, that's a 9. And with 10 minus 9, it's a 1. That's a very basic maths. Okay. So same questions are asked. Okay. So just solve those. Now, though someone asked me convergence, so it's not a convergence, it's a covariance and the correlation. Those are very similar terminology you will heard. Okay. So we will first see the difference between two. So these are very similar terminology, but very small difference between them. So covariance indicates the direction of linear relationship between variables. Okay. So this is a kind of a formula to calculate. So x, I minus. So you will have the two variables x and y. So these are the samples from x and these are samples from y. So you will do the xi minus, this is the mean, and then you will subtract it by the number of samples you have. So this is the basic formula between the covariance. Can I show the last slide? Yeah. Just take a snapshot of it. Well, we see. So hope I think you took the snapshot. Okay, we'll move forward. Okay, so this is formula for covariance and this is formula for correlation. Okay, uh, covariance help you to know the direction means of the linear relationship means it's like mm, uh, example of this okay linear relationship if the price of kind of uh, uh, okay so let's consider the price of onions. Okay, if the price of onions increase, so what you are going to do, you are going to purchase the less amounts. If the what you can say price, if the price increases, then you are going to purchase the less. It's kind of an inverse relationship. So that is one of the example. Another example means if your salary is going to be increased, your spending is also going to be increased. That is another example of a positive relation. Okay, so with the help of covariance, you are able to kind of you are able to with the help of covariance you are going to show the relation between the two variables. So right now I gave one example of positive means where my relation is positive means if I'm earning more then I'm going to spend more. Means if you are earning 1 or 2 lakhs a month, then you are going to spend, you are going for the holidays, you will purchase the bike, so your expenditure is also going to be increased. So but if you're just if your salary is just 10 or 20K, you are not going for the holidays because it will take your whole year salary to go for the holidays and all. So that what you can see the positive relation. Okay. So if you consider this is expenditure and this is your salary, then it is give you the some positive value. Covariance value will come positive. In case of a negative, if you consider, then take onion prices and your purchase what how many you are purchasing. Then onion prices increases, your purchase going to be down. Instead of onion pakoras, you are going to make a cabbage pakoda in your home or the aloo pakoda, something like that. Okay. Similarly, when you go to the goal, means Pani Puri and all those stalls, they are trying to give you other veggies rather than the onion and all. So that's what exactly this kind of relationship you can get from the covariance. Okay. Another important thing, covariance value are not standardized. So the range is from minus infinity to the plus infinity. So there is no range for the covariance. You all get any value between that. Value can be anything. So that's what I just told you. This is the formula to correct. Now, what's difference? What makes it different from correlation? So correlation measures both the strength, it measuring the strength and direction of linear relationship between two variables. So here two things are coming. First one, it is giving the direction, which is already done by job done by the this, as well as it's giving you a what's the strength, how much it is stronger relationship. So someone will say tell that the relationship is positive, but how much strong positive means how much my salary increase means increase my expenditure. If someone who is not who not go outside or not do outing and all, so his expenditure is very small, even though if his salary increases. But someone who go and go the outing and all those things, his expenditure is going to be increased. So the relationship between both person one and person two are different or different for different person, the relationship is different. Okay, even though it's a positive relationship, even both are going to spend money when their salary increases, but someone is kind of conjuice guy or someone is kind of a very free guy, he will spend much more money or something like that. Okay, so that strongness will tell over here. What is meant by direction and strength? So direction means Um, it's kind of a inverse or the means it's proportional or the inversely proportional, that kind of thing. If your salary is increasing, then your expenditure means how much you are going to spend on your family, on your different expenses. So these are kind of one of the example I gave to you. Okay, so that's what exactly I mean here by strain, means I mean by direction. If someone if it's proportional, then it's kind of a relationship. If inversely proportional or the proportional, that's what kind of a direction what I exactly mean here. And the strength means how much. It's kind of a you can so its range is between the -1 and 1. So if it's -1, it means they are negatively correlated with each other. Okay, means if A is increasing, means if you take the two events, if A is increasing, then B will decrease. And how much means -1 means extremely. If A is increasing, it has so much effect on the decrease of B. Okay, so let's example of this particular negative relation. So right now you heard about the DeepSeek, which is the competitor of the AI chatbots. Okay, competitor for the chat GPT and all. So I think you are learning about the AI and all. So most of you are know the chat GPT. Okay, so chat GPT is the biggest player in the kind of a preparing the chatbot and the LLM models. Right now, some guy from the China coming. Yeah, so covariance is basically you are getting the value, means you are getting the negative or the positive value that will from minus infinity to that infinity. So based upon that value, you can say whether it's a positive, means whether it's proportional or inversely proportional. So that's what covariance. But here they make it more standardized way where you are getting covariance as well as, means where you are getting direction as well as strain. Okay. So we are talking about the example of DeepSeek company. So that is a competitor of ChatGPT. So they came and they created same LLM model with means around 40 to 50 people with around 6 million rupees. They created a DeepSeek model, and that was huge, and that they make it open source. Okay. Uh, yeah, it does not have to be the range for the covariance. You don't have the range. It's lying from minus infinity to the infinity. Okay. Moving towards, for example, so they created very simple model, which they make the open source. Anyone can use. So for now, people who are doing ChatGPT subscription, they have to pay some 1800 or 1200 rupees per month. So right now they made it open source. So right now they launched something, and that's why the stock market of the particular means launch of the DeepSeek decrease the means value of ChatGPT company. That also have the effect on the Nvidia company because they are producing the chips. So here the relation is negative here. Means means the profit of DeepSeek or the famous of DeepSeek dropped. What you can say, I'm not able to find getting the exact word. That will there is a very much boom of Nvidia in the US stock market. Okay, uh, since 1 or 2 years when the AI booms come, because people requiring much more chips. Okay, those chips are not going to the China, not provided to the China. So with the help of previous whatever the chips or the computers they have, they prepared a small model. So here the DeepSeek becomes famous. If you consider the famous relationship with DeepSeek becomes famous. Okay, whereas Nvidia becomes less famous because their stocks going to be increased because they did this with the help of less number of chips, and they also made it open source. So famous of one making means both are not getting famous at the same time. So one is getting famous advantages, and one getting disadvantages. Their stocks decrease, whereas the stocks of you can say DeepSeek parent company increase. So if you consider in terms of the monetary values, okay. So that is what exactly the inverse relation. And positive relation, again, considering the similar example. So when the chat GPT launched their particular product, okay, so at that time they told that it requires, if you want to build a similar models, you require more competition power. So at that time Nvidia stocks in the US market booms. Okay, because for the building such kind of LLM model you required the particular computation. Okay, and that's why even ChatGPT launched that particular product, so they are getting so many customers, and similar customers want to build their own LLMs. large language model. So here the stock of, you can say, the stock or the market value of open AI increase. With that, also the market value of NVIDIA company also increase because they are producing the processor and the GPUs and all. So here, with the help of this example, hope you understood the negative and the positive relation. So with one company, NVIDIA stocks increase suddenly, uh, and with one company within one day, they lose around $6 billion rupees within the one day. So that's what exactly the relationship, positive and negative relations, you can consider. So this is the formula. Here to calculate the correlation, you have to just take a covariance. First, calculate the covariance between x and y, then standard deviation of x and the standard deviation of y. So this is the formula. We will see this formula example in the next slide. So these are kind of a properties of a joint distribution. If you have the two distribution x and y, so you have to calculate the infinity, and this is the expected value. So correlation between the x and y is this. That's what exactly we discussed here. So this is the symbol of correlation x and y. This is the standard deviation, means this is the correlation, and this is the covariance between x and y, and this is the variance of x, and this is the variance of y. Okay, so this is write this formula. So we will see the numerical based on that. So this is the question: if two random variables are independent, okay, what can we say about their covariance and correlation? If two variables are independent, okay, they are not dependent of each other, what we can say about the covariance and correlation? We already talked on this, means we already saw one example on that where I explained one numerical. So it's just a kind of a, just a different way to ask the same question. Yeah, so covariance is zero and correlation is zero. So yeah, two events are independent from each other. So covariance can be any value. Covariance can be any value. Yeah, Sahitya, it's true, but it can be zero for the independent case. Okay, so that's why the first option is the correct option. Okay, moving towards next. The correlation coefficient between x and y is 0.6. The covariance between them is 25. Then find the product between the variance of both the variables. So that's simple formula. So here I give the correlation coefficient, I give the covariance, and I ask you to find the probability of, I ask you to find the product between the covariance variances of x and y. So it's very simple, I think. Correlation is equals to variance plus individual variances. That's what exactly the formula. Okay, so we'll go to the answer. It's a B answer. Uh, so this is how it is calculated. Here you have the 25, which is your covariance, 25. 0.6 is the correlation coefficient, that is 0.26. So when you go, I asked here you to use the product of these two. So I flip here, 2.5 divided by 0.6 is the 4.6601, 667. Someone answered it as a D, 36.99. I don't know why you answered that. Or let me check 25. Okay, I will check that in calculator. Maybe it's a 25 by 6. So 25 divided by 0.6. 0.6. Yeah, it's a 4.6. So yeah, my answer is correct. I thought I did mistake on because both of you giving the D answer. So the correct answer here is D. Okay, B. So this is also kind of a, kind of a tricky question. They just ask you the product, and you will be like, in our mind generally when we solve such kind of question, we generally have in mind that they are going to just ask us one value. Okay, sometimes they might ask you the product, so it becomes single value. Okay, that's how you have to give the answer like that. Otherwise, you will think they are not give. There are four entry in this formula: one, two, three, four, and we have to give three, and then I will find one. Here you have two quantity. If you and you are searching here, and means two quantity means there are four entity, and just they give me two, and this is the wrong question, then you will lose your marks. So we will go to the arch and we will see the how you can convert that p test and q test. So Okay, I think before going into that, I think we should go first. First, we will see other things and then we will go. So, hmm, now another topic is the right now we will go a bit fast. Okay, there is another concept called statistical sampling. So, first, understand what exactly population means. Set up all possible outcomes of random experiment. Okay, so uh, can you explain dependent and independent? And dependent and independent is very basic. If you dependent on something, it's called to be the dependent event or variable. If you're not dependent on that particular specific thing, it's called independent variable or independent person. It's a, it's the, it's day to day life, as we see. So that way you can interpret. Okay. So population means whatever the outcomes are coming, okay, that is called to be the population. In 1 to 6, if you throw the die, 1 to 6 are coming. So all the 1 to till 6 is called to be the population. And if you take some part of it, that is called to be the sample set. So let's consider sampling help. Why where I am confusing maths and in my real life. So uh, uh, okay, independent and dependent. Okay. So we will go through that, and I think at the end, means it's already 8:42, and at the end I will just ping me. I will explain what with the help of other examples. I will try to explain it right now because other also wants means might want to go because it's already we are left with 15 minutes and we have to solve other numericals too. So sample set. Okay. So samples. So this is population means I gave their here example. Let's consider this is India from different parts of the India. These are the peoples, and all here, all this represents population of India, each in one of the entity. Sample statement, finite set of observation obtained from this experiment. Now I want to measure the average height of my whole India. So you will not go and ask the height of each one of the billion people. Instead of that, what they will do? They will go to the different states. They will choose both female, male. They will choose persons from the different what you can say ages. That way, they are going to form. They are going to take a different samples, and that way they are prepare a particular sample set. So out of billion population, they will choose the million people, and when they calculate the height of those million people, and based upon that they will say the average height. When someone will say you the average height of whole world is this particular 4.5 inch, that does not mean they went to each person and calculate that height. They took some portion or particular people from that here from that place, and that's how they are calculating the that what exactly the sample space. So why we are calculating sample helps to make some inferences about the population. So right here, what inference I want to make? I want to calculate the height, average height of my Indian population. So that's what inference I want to make. The inferences may be uncertain because sampling might be uncertain. Okay. So let's what exactly is inference mean. Sometimes whatever the inference you made or the average height you are talking about, if you took the wrong people, if you want to calculate the average height of the whole India, and if you are just taking the people from the Tamil Nadu, okay, and calculating means you are taking some million people from the Tamil Nadu and then just calculating the average height of all those people, then you are biased here. You will not consider different people, or you are just taking the male candidates. That means you are ignoring the female candidate, but there is a significant amount of the population in India that is male as well as child. So you have to, so that's why your sampling should be very proper. So one of the you talked about in the news you heard about TRP and all. So they are not going to each one of the house and taking what channel this particular person is watching. So instead of that, they are installing that TRP thing in different places, and they are based upon that thing. Those samples they are kind of generating the TRP. And when they talked about there is some what you can say these are fake TRP and all. So that means they did something with these whatever the samples they chose bias sample. They chose means only those who are watching some news channel which are oriented for particular politics, political party and all. So that's what exactly means. So to make a proper inference, you have to do the proper sampling, which represents your whole entire population. So that's what exactly called to be the statistical um, uh, sampling. So with the help of statistical sampling, we are going to do the statistical analysis. So the statistical analysis can be done with the help of two-way descriptive and inferential. So descriptive means we will provide the graphs and the numerical value based upon that, and then we have inferential, the hypothesis testing and the estimation and all. So we'll see each one of them. So graphical statistics. So with the help of let's consider beach in the Goa. So this is the average daily temperature, and this is particular in the this is in the degree Fahrenheit, not in degree Celsius. Okay, and this is the scatter plot of how many visitors increasing. So in this case, you can see as much as your temperature is going to be increased, the visitor means visiting the beach is also going to be increased. Okay, so with the help of that you can say that I want to sell something. So if it's a if so you want to also maintain your inventory. So in that case you will if that you will see what's going to be the temperature in the morning. Based upon that you will purchase your inventory for your particular hotel. Histogram, so this is what I am talking about, and this is you can see the bell shape. If you calculate your body temperature throughout your day, so you will get a bell shape, and your generally mean temperature. So throughout your day, your temperature is going to be changed. Your temperature is not going to be constant. So 98, they generally say that temperature should be 98 point something. So this is the normal temperature. So this is the bell shape here. Okay. This is the box plot. So there are different plots. So here box plot represents how many particular samples. This is the median value it represents. This is the quartile one, how many samples below 25% quartile and 75% quartile. This is the minimum value and the minimum maximum value. So how much this is spread given over here, that is represented with the help of box. So you can go and in depth and then you can see on the internet what exactly this means. Now, numerical statistic means the mean value, median value, that what we calculated. So that all comes under the numerical statistic. Okay. So mean in the average norm. So this is the football player who goals. These are the different goals in the different matches. So when we talk about mean average value of that particular person, it's fine. So he in every match he is going to score at least means generally his average to score in the match is 5. Then median value, it's a middle value means if you arrange all those values, so what is the middle value? So here 6 is the middle value. If you arrange all those, what is more? How many frequent times he score a particular value? So he score 6 two times. Okay, so that is what exactly here. More talks about frequency. This talks about central tendency, and this talk about average thing. Okay, range means from how many range. What exactly the range of this particular footballer? So in cricket, I think most of you are not familiar with the football terminology. So let's talk about the cricket. So in cricket, there is the economy. How many runs particular bowler have in 1 over, then average strike rate, that is called to be the average and all. So if you have 100 strike rate, that means you are scoring 1 run in one ball like that. So there are different index that is told to you. Based upon that you will get and you will reach to the answer. So if you say which player is the better, so based upon strike rate you can directly tell. He might be he is performing better in one match, another match he is not, he is out on zero. But when you talked about the strike rate, when you want to compare the Sachin Tendulkar and the Virat Kohli, just look at their strike rate and how many centuries they have done. So based upon that, you can make sense out of who is the better player and all. So that's why we are going. Another thing is the hypothesis testing. So this is the testing used to make decisions. Okay. So example, whether company stock yield profit, that desired value. So I gave some value. My CEO gave we want to achieve this particular thing. So based upon different parameter, we will form a particular test and we will check those tests. Whether the effect of drug A is similar to drug B. So particular industry firm, initially they have drug A in the market, they prepare another advanced drug B in the market. Now they will test whether which drug is a particular better drug. So that is way we are going to do the hypothesis testing and all. So hypothesis testing is generally convert to a test of mean and variance parameter of population. So that what so there are two kinds of test. One is two-tail test where we are going to consider this all the tails, and this is the do not reject hypothesis. So we will have some condition. Okay. So if your value comes within this condition, okay, we are going to accept. Otherwise, we are going to, if your value coming in this region, we are going to reject this. So this is called two tail test. It's below this some value or after this some value. And this is called one tail test. So this is only we are going to reject from the lower tail or the upper tail like that. So we will see this with the help of an example in better way. So what exactly is null and the null and alternative hypothesis? So right now there is a farm and there is a fertilizer company which prepare a particular fertilizer, biofertilizer. So application of biofertilizer X increases plant growth. That is your H1 means alternative hypothesis, or you can say H1 hypothesis. Null hypothesis, application of biofertilizer X do not increase plant growth. One thing here you should take here that you most of the time means almost all the time we want to reject the null hypothesis. So that way you have to prepare your formulation. Okay. So here formulation is application of biofertilizer like do not increase the plant growth. So you prepare some biofertilizer and that increases the plant growth that what exactly you want. So alternative of that is that fertilizer had don't have any effect on the plant growth. So that's what given over here, which is taken as a null hypothesis, and the alternative hypothesis that what we want to say. Okay, so let's errors in hypothesis testing. So while performing this hypothesis testing, there might error happen because if these are considered this is null hypothesis and this is alternative hypothesis. But there is a particular portion, okay? If you choose some threshold here, there is a particular portion where your values might cool means this particular region is both in both hypotheses. Even if you choose one value, there might be some error will come. So those errors are called to be the type 1 and type 2 error. Just take a snapshot of it because of the time we are going fast. Just take a snapshot, and I think by reading this, you are able to know what exactly I mean. So we will go to the means we will go fast and we will see the numerical. Uh, okay, so this is Z versus T test generally going to be utilized in the numericals. So Z test use when population variance is known. Okay, here I'm talking about population variance. Okay, there is another variance that is sample variance. So don't confuse between that. Population variance, you know the true variance of your whole population, and sample variance means you out of that population you will take some 10 people and calculate the variance of that 10 people. That is a sample variance. When you know the population variance, at that time we are going to use Z test. Use generally for the sample size greater than 30, and based upon normal distribution, this test is calculated. So this is the formula for that. So here this X mu means population mean and X bar means your sample mean. Okay. So population is the true mean and sample means you will take some 10 people and this that if you calculate that that's sample mean. So don't confuse between these two means. Okay. And this is the standard deviation. Okay. Next, use when variance is not known. So here variance is known, here variance is not known. So that way you can use the t-test and the z test. Use for sample with less than 30. It is more than 30. Based on student t's distribution test. Okay. Okay. So like this is the formula for that. So basic difference here is different in this particular S value. Here you know the population variance. Here you know the sample variance. Okay. So S represents the sample variance. Okay, so let's go this example. A teacher claims there is one teacher in the class which claims mean score of student in his class is greater than 82 with the standard deviation of 20. If the sample of 81 student was selected with mean score of 90, then check if there is enough evidence to support this claim as 0.05 significance level. So what exactly this significance level? Significance level you can consider this is the probability. So I can tolerate whatever she is claiming, I can tolerate till this limit. If this limit exceeds, okay, so this limit you will get from here, okay, this particular limit. So this is particular x value, okay, let's consider. And for whatever the area under cover under this, we can convert this area into the probability format. So that's what we saw in the here, which slide? Okay, I will go through that. Okay, so here is the way to convert that into the probability. So this is ranging from 0 to 1. So that's what similarly we are doing there also. Okay, converting it into the probability. So I will go directly on one into the numericals. Okay, okay. So this is our numerical. So some teacher claims something, and we want to test whether what she is claiming is true or not. Okay. So number of student it's 81 given. Here population mean is not given, so we are taking sample mean. Okay, so she chose 81 students out of all students. She not chose. Let's consider if in the class if 1,000 students are there, she not chose all 1,000. She just chose 81 student. Okay, the population standard deviation also given, that is a 20. So here uh, uh, it's the variance is given deviation, and that's why we are utilizing the formula, and where we are utilizing the z table, means or standard deviation table we are utilizing. So from Z table, here kind of hypothesis we build. Generally, we want to reject the null hypothesis. So here claim is it's greater than 82. So I made it is equals to 82, and we want to claim, we want to reject this hypothesis. It should be greater than 82. That's my alternative hypothesis. So this is the formula. So in that formula, you put all those 90, 82, 20, and under root 81 like that, and you will get the how to select H0. So select H0, the hypothesis you want to reject, means I want to go against that hypothesis. So here what she claimed, that a teacher claimed that mean score of the student in his class is greater than 82. Okay, so it should not be 82. I think you can. It should not be. It should be. It should not be is equals to 82 or less than 82. That kind of alternative hypothesis you can make here. Less than 82, that is I think a better way to make this a hypothesis. Okay, generally we make the is equals to hypothesis, uh, that is a usual way. So here I'm my alternate hypothesis, it should be greater than 82, so I want to reject this 82 claim, or you can say less than 82 you can consider for now. Okay, for the assumption. Okay, so here I put all those formulas, so I will get some z score out of it. So Z score is basically 3.6, and here I will accept if the probability is 0.5 or something like that. So for this 0.5, I am getting 1.648 value. So here all this P norm and Q norm I am calculating from the R Studio. So where you want to go, so from Z statistic you want to calculate the probability. So you have to just write here P norm. Okay, so minus 2, 0, 1, all these are mean and the standard deviation value. And this is kind of a minus 2 is the particular exact value on that line I'm giving. So here I'm running that code, and you will get all 0.022 probability. So I'm talking about some, okay. So here I'm talking about like this. This is your particular your curve with mean something and standard deviation. Let's consider assume one curve. If this particular value given to you and you want to know probability of this value, so you will calculate the area under this value and all. So that's what give you the probability of that value. So that's what given over here. uh, Okay, so that's what we are converting here, and that can be with the help of P norm and Q norm. You can calculate, convert this 3.6. You can convert this 0.05 significance level to the particular number. So this is the probability. You can convert this probability to the number form. It's just a mapping. And here, as 3.6 is greater than 1.645, those null hypothesis is rejected. So I will give you another example. I think that will be better way to understand this. So this is the another example. I think with the help of graph, it becomes more easier for you. A researcher want to test whether a mean weight of sample of 50 apples is significantly different from the claim population mean weight of 150. The sample mean weight is 149 gram, and the sample standard deviation is 10 grams. Calculate the t-test statistic for this. So we are going to use t statistic for this. So d degree of freedom is we have 50 apples, so n minus 1 is 49. Number of apples we have 50. We have population mean, that is 150. Sample mean we have 149. Standard deviation is 10. So here we are choosing mu is equals to 150. Okay, we want to reject this hypothesis. Okay, mu1 is not equals to 150. A researcher want to test whether mean value of sample of 50 apples is significantly different. We want to test whether it's different from the claim population, which is 50. So we want to reject that file. We choose alternative as not equals to. Okay. Mm, can you please show? Okay. So this is the previous slide. Okay, he just want to test whether it's a mean value is 150 or not. So it's either equals to 150 or not equals to 150. Okay, one more. So these are the formulas. I think Kamachi wants the slides. Okay. Just take a snapshot. Hope you took this if you want. Okay. Okay. So this is the another example. Here we have all the values. So for from the T table, this is called to be the T table, from which your alpha values, okay, are 1.667, which is a 95% of the confidence we took here. That is 0.05. Uh, that is a 0.05 kind of a confidence level. This is calculated using R stroke PT and QT. So this is the formula, and you are getting minus 0.70. So let's understand this with the help of this figure. This is the figure where you want to, it's a two-sided test. If your value, this is particular minus 1.676, you are getting, this is the particular value. For this value, you will have the probability of 0.05 confidence limit, and all your data will come under this 95%. So if it's either less than minus 1.676 or greater than 1.676, in that case, you are going to reject this particular claim what he is making. Okay. Whether right now our value is minus 0.7071, which is coming here. Okay. And which is coming in the accepted region. So here, whatever the hypothesis we claim here, okay, the null hypothesis is accepted in this case. Okay. So that's how this is the way to understand with the help of figure. So you will calculate this T statistic or Q statistic. T statistic or Q statistic is basically a this value at this particular point. At this particular T, what's the value? Okay, that what it is about. Okay, and then you will calculate for this particular what's the probability. So then what exactly confidence interval 0.05 means till 0.05 I will accept, means it will come here, but below 0.05 with this region will come, I'm not going to accept, okay, or if your value comes here. So that's what basically a hypothesis testing is. So right now I think we already done with the timing 9:03. So if you want to leave, so that's what we took the example. Just go through these examples. I will share the slides that will help you to just solve this, understand this. Um, because of the time, I finished it very fast. I think. Uh, Also, go to the professor's example that will help you to understand and answer this kind of questions in the probability. So those who not able to find means how to convert this number into the probability. So for that, I'm also going to share with you this file. So this is p-norm means normal distribution parameters are mean and standard deviation. So I give mean, standard deviation, and this is lower tail. I want to do the lower tail side test. So that makes it 2. So I run this code, and then you are getting for the -2 value, you will get the probability. Okay. Ra- You're getting probability of 0.027. Uh, for zero value, you are getting 0.5. So when you have the standard deviation, standard normal deviation, you have mean 0 and 1. And at 0, that means 0 and 1 means your probability, because in this curve you are able to see if this is the standard normal deviation, 50% of the whatever the you have area, it's below 0, and that's why it's 0.5 area divided by whole one area, that means 0.5. That's what here you answer is probability 1. So similarly, if you want to do inverse of it, so it's like give that value and you will get the uh, give probability and you will get the kind of number value like that. So that's it for today. If you have any question, we will you can leave the call if you don't have any question, and if someone has a question, we will see. Are we having the recent research papers related to this calculation and experimental model developed using? I think Kamachi don't I don't think there is a requirement of the research paper for all these things. Just go on the Google, and there are many blogs on analytics within there, and then medium.com. You will find so many articles which are talking about this particular kind of a test. Or so for the basic things, don't follow. I think it's not good to follow the research paper. If you are going deep down, then it's okay to go through research paper. To relate with real life example, yeah, in medium blocks they will give the real life examples. So with the help of that, you can just understand where it is going to use. In research, it means every research or the chemical in I'm from the chemical engineering, so whenever we do the catalyst and all those things, so we are going to reject some hypotheses and all. So in that paper you will get, but it's better to go with the blocks. Any sample block name. So go to medium.coms. They have very standardized blogs, as well as the Winda Analytics is one of the kind of a website. They have very good quality contents. Or just ask to ChatGPT. I think if you're familiar with the ChatGPT, just go and ask ChatGPT. Give me a different examples on the real life examples of uh, hypothesis testing. I think I don't know I have open or not ChatGPT here. If it's open, we can just I will show you. So right now, try to use ChatGPT and all stuffs. Those are the very advanced stuff. I think it's I don't know. Okay, I have to log in for this. I will not log in here, but just go through ChatGPT if you have login credentials, and you can do that. Okay, can you share the R Studio code? Yeah, I already I think uploaded the R Studio code for other 2 weeks. So for this week also I will upload as well as slides and the PPT. No worries. So thanks for today. Um, I think someone asked about the independent and dependent variable real life uh, examples of that. Um, okay, so another example of real life example of independent and dependent. So this is from my personal experience from the when we researcher in PhD work on the projects. Okay, so we have two kinds of research students, research scholar. One is the one who does the experimentation, who go to the laboratory doing mixing of the chemicals and find some result, and another group who are doing the modeling and doing the computational part. Okay, so those people who are doing the experiment, so they have to rely on someone from the external source for their chemicals, for their equipments. Whenever they prepare some kind of a good material, they want to test that material, so they have to imply on some testing agency or testing facility. So right now here their performance sometimes performance you can say performance or their output is dependent upon external agents or the vendors who are supplying all those things to them. But in case of another case, the case of a computational guys or who is doing coding and all, okay, or performing artificial intelligence, they are not dependent upon the vendor because even the vendor is coming, not coming, they don't have to do anything. It's all they have the computer, they just have the computer, they can just do the code and all. So that is very simple. That is kind of a real life example of dependent and independent. Okay, so that is one of the real life example of dependent and independent. Uh, in mathematic term, uh, um, mm, okay, in mathematic terms, so example of this is kind of uh, I will give the dependent example. If you want to calculate the area of a rectangle, okay, so um, it is dependent on what factors? It is dependent upon your length and the breadth. Okay. So if someone just gave you the means if your length is going to be increased, your area is going to be increased. So that's what you can say the dependency of the length and breadth. Okay. In the kind of uh, in the day-to-day life or the study or the mathematical formation of dependence. Okay. And independent Let's consider the example of a circle. You have given a chord of a circle, okay, and someone asks you to calculate the area of a circle. So just using the chord, you can't calculate the circle area if it's not diameter. Diameter is also one of the chord. So that way, um, so circle area is dependent upon your radius. Okay, that is the independent, you can say. That is circle. That is the dependency of area on radius. If you check the dependency of chord of your particular circle and the area, so they are independent from each other. Area is not dependent on that. So this is a mathematical example you can consider. So hope I think that clears your doubt about independent and dependent. So thank you from my side. You are free to leave the call. I will upload all the recordings and all on the website. Just to go through it and solve your numericals. So thank you to all. Uh, Hope the sessions you are understanding. Uh, Thank you.